Hello, everybody. This is part 2 of the video before. I forgot one other little section of something we needed to go over for today. So this is going to be quite a bit shorter, but we're just going to talk about how light travels. So now light travels in straight lines at amazingly really high speeds. You can probably think of like the speed of light, light speed, which is faster than we could ever really comprehend. Now, light can travel through solids, liquids, and gases. Light can also travel through a vacuum, which is an area that has no matter at all. It's completely devoid of matter. So light can travel through that. Light can also travel through liquids, solids, and gases. Now, the speed at which light travels through a vacuum, which is nearly 300 million meters per second, because there's nothing blocking it, is believed to be the fastest speed possible in our universe. So light already travels faster than anything else in our universe. And so when it's in a vacuum, it travels especially fast because there's nothing to stop it, nothing to block that light. The speed of light varies according to each medium, meaning light is going to go a little faster or slower depending on what's blocking it or what it's going through. Now, light travels through just the air around us almost as fast as it travels through a vacuum. So as the light from the sun is just reaching our eyes, travels incredibly fast. Light travels a lot more slowly if it's going through liquids and solids. Okay, so light can travel through the ocean, for example, and the warmth and the light from it can travel even to the depth of the ocean, but obviously it slows down because they're starting to get less and less the further down you go. And through solids, it also travels much slower. Now, the denser the material, the more slowly light travels through it. Something that this unit doesn't get into too much, but we do want to talk about a little bit is also the heat energy from the sun. And so a lot of times objects may not seem like they're getting lots of light, but the heat that they're getting from the sun is what you can really tell is going to that solid. Now, light travels a lot more quickly than sound does. We are going to get into sound waves as well, which is sound is an energy which travels in waves just like light. A simple demonstration of this is lightning and thunder. Now, when lightning strikes several miles away during a storm, we see the lightning very quickly. So as soon as it strikes, basically, you see it immediately. But it might be several seconds before we hear the thunder that accompanies it. The light has traveled the distance between you and the lightning more quickly than the sound of the thunder. Jet airplanes can fly at several times the speed of sound. So something man-made, a plane, can travel actually faster than sound. But no human-made machine can or probably ever could travel as fast as light. Now, light travels in straight lines or rays, spreading in all directions from a source. Light cannot bend or curve around objects without help. We are going to get to when light appears to bend. And when it actually does, through help of some kind. The light itself does not, but the object might cause it to. Now, shadows form when light from a source is blocked by an object. Okay, it's pretty easily seen, like in this, let's see. Kind of see a shadow there. When that light is being blocked, there's darkness right here, the shadow from the light not being able to pass through this solid object. If you have ever observed a shadow, then you're familiar with this property of light. Shadows form when light from a source is blocked by an object. The closer an object is to a light source, the larger the shadow that is formed, which is a really cool experiment if you're able to see that the closer you are to something, the smaller the shadow, or the closer you are to, let's see, like this. Yeah, if the light source is closer, the shadow itself is going to be bigger. Shadows created when a light source is above an object tend to be short also. So if the light source is above, then the shadow will be short, and shadows created when a light source is to the side of an object tend to be long. So it's going to be difficult for me to show this in video, but I'll have a video, an extra video attached where you can see this in action a little bit. And if you've got a flashlight, I bet many of you do, or if not, you could ask your parents to borrow their phone and try out their flashlight to test it out on objects right up above and then to the side and see how the shadow changes. Also, how the shadow changes depending on how far away you are to the light source. Okay, that's all for this little extra portion of light. We're going to continue getting into some really fun things. This is one that really requires a lot of hands-on learning. So I wish that we could do more of this, these experiments together. Hopefully you do have flashlights and things at home where you're able to see all of this in action though. Talk to you soon. Bye.